In this video, we will solve a problem on consumer surplus that was asked by a brother on Telegram channel of Economaths. The question was like this. The demand function is being given as y is equal to 85 minus 4x minus x square, where y denotes the price, x is the quantity demanded. Okay, so this is our inverse demand function. Find consumer surplus for price is equal to 64. When price is equal to 64, we have to find out the consumer surplus. The options were given as 36, 34, 38 and 32. Okay. Now, how do we calculate the consumers, and basically what does the consumer surplus mean? Consumer surplus is simply the difference between the price that a consumer is willing to pay and the price he actually pays. Okay, this gives us the consumer surplus. Graphically, consumer surplus is nothing. It is an area which is above the equilibrium price, okay, above this red line, and below the demand curve, which is this black line. Okay. Now, how do we calculate then the consumer surplus? We need to first figure out the area of this region. Okay, so this region we have to take the area of this region. From this we will subtract this and the expenditure of the consumer, and whatever is left is our consumer surplus, that is the upper right triangle. Okay, basically what I have done, first I have written this demand function as it is. Okay, now we are being told price is equal to 64. First we need to find out the total expenditure. Okay, we need to find out the total expenditure, and we know total expenditure is simply price into quantity. Price is being given us as 64, we have to find out the quantity. So if price is equal to 64, so in place of y we have 64. We solve this demand function, put y is equal to 64, and we write 85 minus 4x minus x square. Then I just transposed this minus x square minus 4x, and then subtracted 64, subtracted 64 from 85, and I got 21. Okay, so x square plus 4x minus 21 is equal to 0. This is our standard quadratic equation. Okay, we can solve this by splitting middle term. We should get two numbers such that their sum should be equal to the middle term, that is equal to 4, and the product of the same two numbers should be equal to minus 21, and the numbers were simply 7 and minus 3, and 7 into minus 3 will be 21. Okay, so we got x square plus 7x minus 3x. So 7x minus 3x is 4x, plus in place of minus 21 I have written 7 into minus 3. 7 3s are 21, and we have minus, obviously. Then we factored out x from the first two terms and minus 3 from the last two terms. Okay, and we got this x minus 3 into x plus 7 is equal to 0. Okay, that means either this x minus 3 is equal to 0, or this term x plus 7 is equal to 0. If x minus 3 is equal to 0, which implies transposing this x to RHS, it will become positive 3. Or when x plus 7 is equal to 0, which implies x is equal to transposing this plus 7 on RHS, it will become minus 7. Now x is our quantity, and quantity consumed cannot be negative, so we will discard this negative value of the quantity. So what we got here, we got the quantity equal to 3. Our price was 64. Then total expenditure is price into quantity, 64 into 3, which is 192. Okay, now the consumer surplus is, as I have told, first we need to consumer surplus is the area which is above the equilibrium price and below the demand curve. So the area of this triangle. Okay, how do we calculate the area of this triangle? To calculate the area of this triangle, first we need to calculate the area of this whole region. Okay, this whole region, and from that if we subtract this rectangle, we will get the area of the upper region. Now area of this whole region is being given by the definite integral from 0 to equilibrium quantity which is 3. So x is equal to 3. Let me write it here in place of x, and take the integral of this inverse demand function. Okay, we have 85 minus 4x minus x square dx. So this part gives us the area of this whole region. Here the area of this whole region. From this we subtract this rectangle, which is y into x. Okay, so the integral of 85 is 85x by rules of integration. If we have x to the power n, it is integral is simply x to the power n plus 1 divided by n plus 1. Okay, we add exponent by 1 and divide by resulting exponent. Okay, then the integral of x is x square upon 2 minus the integral of x square is x cube upon 3, and evaluate it from 0 to 3, and from this we subtract p into q, which is y into x here, that is the total expenditure 192. So we have 85. First evaluate it at the upper limit. So in place of x's we put 3's, so we have 85 into 3 minus, so 2 1s are 2 2s are 4, we are left with x square only. So 2 into x square is 3 square minus x cube is 3 cube upon 3 minus 192. When we solve this, this comes out to be 85 into 3 is 225, 3 3s are 9, 2s are 18, so 3 3s are 9, 3s are 27 upon 3 is 9 minus 192. This gives us 225 minus 209, which gives us the consumer surplus is 36. So the correct option was 36. Okay, so this region means taking this and taking the definite integral of demand function from 0 to equilibrium quantity. Okay, so this region denotes us the area of this whole region is being given by this integral. Okay, from this we subtract this p into x, that is y into x in this case. Okay, minus, and when we subtract this rectangle from this whole region, we are left with this small triangle, and this gives us the consumer surplus. Okay, I hope I make myself clear in this video. Thank you. For more videos on mathematical economics, please subscribe this channel, like, comment and share also. Thank you.